Hello class. For my FTE project, I am making a 3-part video series to cover science, language, and history. My topic is the Kuiper Belt. What is the Kuiper Belt, you may ask? This is the Kuiper Belt. This picture may not tell you much, so I will explain. The Kuiper Belt is an area of space beyond Neptune full of an estimated 100,000 icy objects that are over 1 kilometer in diameter. It contains at least 4 dwarf planets and a large variety of smaller icy objects, binary systems, dwarf planets, and other interesting things. Let's start with dwarf planets. Remember in 2006 when Pluto lost its planetary status? First of all, Pluto defenders, there is a reason for this. This guy. This is Eris. Discovered in 2006, it was the final nail in the coffin to Pluto's planetary status. But it goes deeper than Eris. In the 1600s, a small planet named Ceres was discovered in the large gap between Mars and Jupiter. 4 years later, they discovered another one, then another, and another. For a period of time, kids were learning the 11 planets of the solar system. As they were learning this, scientists were discovering more and more and more similar objects in the same area. The solution they came up with was to classify these objects as asteroids and name the region the Asteroid Belt. And in the 1990s, 60 years after Pluto was discovered, something similar happened. Scientists started finding more icy objects orbiting in the Earth in the same region as Pluto. Sound familiar? Scientists said that as long as they didn't find an object that was bigger than Pluto, it would still be considered a planet. Which was exactly what happened in 2006 with the discovery of Eris. Since there are so many large-ish objects that were found, they decided to make a new category, dwarf planets. Larger Kuiper Belt objects as well as Ceres are put into this category. Dwarf planets have similar characteristics to planets. Some have 1 or more moons, and Pluto even has a small atmosphere. Pluto is probably the most planet-like dwarf planet with its 5 moons and atmosphere. Next up is binary systems. Binary systems is where a satellite, or moon, of an object is more than half the object's size. A good example of this is the Pluto-Charon system. Pluto's largest satellite, Charon, is around half of Pluto's size, which would make Charon itself a dwarf planet if it was not orbiting Pluto. If you made a scale model of Pluto and Charon out of plasticine and attached them with a stick, the center of balance would be on the stick, unlike most planet-moon systems where the center of balance would be on the planet. Pluto is not the only example of this. It is estimated that 1% of Kuiper Belt objects are in binary systems. With the current estimate of objects, that would be 1,000 binary systems. Which brings us to our third and final point of this video, the estimate. It was estimated that there are more than 100,000 objects in the Kuiper Belt, but there's a problem with this estimate. It was estimated that there are a million objects in the Asteroid Belt. This will be okay except for 2 factors. 1. The Kuiper Belt suffers more collisions than the Asteroid Belt. So many that in a billion years there won't be a Kuiper Belt left because all the objects are slowly grinding each other to dust, which would suggest a bigger density than the Asteroid Belt. And 2, the Kuiper Belt has a lot bigger of an area than the Asteroid Belt. These factors suggest that the Kuiper Belt is both bigger and denser than the Asteroid Belt, meaning there are probably more objects in the Kuiper Belt than the Asteroid Belt, making the estimate of 100,000 objects in the Kuiper Belt horribly inaccurate. There are still more points to cover, like its history and science, but these will be covered in additional videos for other tasks.